Okay, let's unpack this. Have you ever felt like you're drowning in information, just desperately searching for those, crucial nuggets of insight, the ones that cut through the noise?
Oh, absolutely. Information overload is real.
Well, today we're taking a deep dive into a topic that feels exactly like that, the existential risks facing humanity, and specifically where artificial intelligence fits into that, well, frankly, terrifying picture.
It's a huge topic and one that generates a lot of fear, definitely.
It does. But we're not just here to scare you, we promise. We're also going to explore a really groundbreaking approach, something that aims to solve AI's most pressing challenge.
Turning something that feels intractable, like the AI alignment problem.
Exactly. Turning that into something far more understandable, auditable, and maybe even insurable.
Which sounds almost counterintuitive for AI risk.
Right. So our mission today is to cut through all that complexity and give you those aha moments. You need to be truly well-informed on one of the most critical conversations happening right now.
Let's do it.
Okay, first up, let's tackle the big, scary question. We've got all these things that could, potentially lead to human extinction, especially thinking short timelines. Where does AI actually stand compared to other threats?
Yeah, how do we prioritize? It's critical.
It really is.
What's fascinating here is how we frame this. Think of it like a doom train analogy. Some AI safety folks use this.
Okay, a doom train.
Yeah, if the destination is human extinction, there are lots of potential breaks or off-ramps, different things that could stop us getting there.
Right, different safety measures are checked.
Exactly. And to feel safe, you really only need one of those breaks to work reliably.
Makes sense.
But if you believe every single break has some chance of failing, even a small one, well, then you stay on that train all the way to the end. That's the core worry.
I see. So how do the risks stack up then, using that short timeline perspective?
Well, if you draw a graph and you weight it towards risks that could hit us within, say, the next 2 decades, surprisingly, nuclear war and natural pandemics actually rank above AI.
Above AI.
No. In the near term, yes. Think about nuclear war. The short-term likelihood is high. We've got around 12,000 warheads globally right now in 2025.
And huge geopolitical tensions. U.S., China, Russia, NATO.
India, Pakistan.
Yeah.
Exactly. And the severity, catastrophic. Even using just 1% could trigger a nuclear winter, potentially killing billions.
It's already here, ready to go.
It's a proven deployable technology with immediate destructive potential, as our sources put it.
Okay. And pandemics.
The natural pandemics also have a high short-term likelihood. They can emerge rapidly with existing tools. We see ongoing threats like avian flu mutating.
And we're talking natural ones here, specifically.
Yes, focusing on natural ones for now to sort of isolate that risk from AI's influence, though AI could play a role in synthetic biology later. The severity is, again, potentially catastrophic. A highly lethal, very transmissible pathogen could kill billions, especially if vaccine development can't keep up.
Right. So nukes and plagues first on the short list. Why does AI rank lower then, given all the hype and, frankly, the fear?
So for the existential risks from AI, things like a misaligned superintelligence.
Meaning an AI smarter than us, but working towards goals that aren't good for us.
Precisely, leading to maybe unintended catastrophic consequences. The short-term likelihood for that is considered moderate. Most experts think these kinds of advanced systems are likely decades away.
Okay, so the superintelligence risk is further out.
Right. We do have immediate misuse risks. AI-driven cyber attacks, deepfakes causing chaos. Those are plausible now. But the truly existential threat, the superintelligence one, seems further off.
But if it did happen?
If it did, the severity is potentially catastrophic. If a misaligned AI starts optimizing against human values, well, that's the nightmare scenario.
Got it. And other risks? Climate change? Asteroids?
They fall lower on this short timeline-weighted list. Climate change has supervolcanic eruptions like Yellowstone, also very low, maybe every 700,000 years or so. And gamma-ray bursts are extremely unlikely.
Okay, so on the surface, that ranking makes sense based on timelines. But you mentioned things get tricky. Our sources caution against comparing AI and nuclear tech too directly, right?
Yeah.
Why does that comparison start to break down?
Yeah, it's intuitive, but it unravels. And this is crucial. It breaks down for 3 key reasons, which also highlight why AI is so uniquely difficult to manage.
Okay, what are they?
First, its far-reaching scope. Nuclear weapons have a focused destructive role, right? Boom.
Right.
AI isn't like that. Its applications are everywhere: economics, warfare, biotech. It doesn't just act alone, it amplifies other risks.
Right. It's a multiplier.
Exactly. Second, AI has non-excludable inputs. Building nukes requires specific, restricted materials, uranium, plutonium, you can track those.
Okay.
AI relies on things like data and computing power. Those are everywhere. They're ubiquitous, which makes containment much, much harder.
You can't just lock up the data centers.
Pretty much. And third, its graduated impact. AI risks scale up from misinformation and bias today, potentially towards superintelligence later. It's incremental. Nuclear weapons are more binary. Huge catastrophe or nothing.
Right. It's not a dimmer switch. It's an on-off switch.
A very big on-off switch.
Okay, so given those nuances, the scope, the inputs, the gradual impact, our sources, then ask a really provocative question. Is ranking AI against these other threats even useful? What's the argument against doing it?
The argument against is pretty bold. It basically says, no non-AI extinction-level risks are both truly independent and near-term enough to clearly outrank AI's extinction potential.
Whoa, break that down.
Okay, take nuclear war again. Its basic mechanism, fission and fusion, is independent of AI, sure, but could AI amplify the risk? Like through autonomous weapon systems making mistakes or AI-driven cyber attacks on command and control? Arguably, yes.
So not truly independent practice.
Potentially not. Then, natural pandemics. For one to cause actual human extinction, it would need to be exceptionally lethal and incredibly transmissible. That combination is extremely rare in nature.
Okay.
So the argument concludes that AI's dominance, or potential dominance, comes from its systemic nature, its incredibly fast development path, maybe 20, 50 years for advanced systems, some predict, and those non-excludable inputs. It makes AI uniquely pervasive and possibly the dominant near-term existential risk, even if superintelligence itself is decades off.
That's a really strong counterargument. It feels like AI is interwoven with everything else. But if that's the argument against the ranking, why did we even do it? What's the argument for saying it's useful?
It absolutely is useful, particularly for prioritizing immediate actions.
How so?
Well, first, it focuses on immediate priorities. Nuclear war, natural pandemics, they have a higher immediate likelihood based on current conditions. So it tells us we urgently need things like arms control, global health surveillance right now.
Okay, practical focus.
Second, it clarifies AI's relative position. By trying to isolate the AI-independent parts of other risks, it really highlights AI's unique technology-dependent nature. That helps us think about crafting AI-specific governance rather than just lumping it in.
I see. Tailoring the response.
Exactly. And third, it drives actionable insights. Emphasizing the risks we can address now, like pandemic preparedness or nuclear de-escalation, builds urgency for policy and research in those areas, while we also work on the longer-term AI problem.
Okay, that makes sense. It helps allocate attention and resources effectively. Which brings us neatly to budgeting. If we had, let's say, a hypothetical global budget for tackling existential risk, how would we divvy it up based on this?
Right, putting our money where our mouth is, essentially. If we imagine, say, a $100 billion annual global budget dedicated to this.
A big number, but maybe realistic given the stakes.
Hopefully. The analysis suggests we need a balance. We'd allocate the largest chunk, $40 billion, or 40%, to AI risk mitigation.
40%. Wow.
Yeah, that reflects its growing systemic nature and its potential to amplify other risks. This would break down into things like $15 billion for actual AI safety, research alignment, robustness, interpretability.
The technical nuts and bolts.
Yeah. Then $10 billion for global AI governance, trying to build international frameworks for things like compute access, model deployment, autonomous systems.
The coordination piece.
Crucial.
Yeah.
Another $10 billion for near-term misuse prevention, fighting the deepfakes, the AI cyber attacks we see now, and maybe $5 billion as a contingency fund for surprises.
Okay, that's AI. What about the others?
Next biggest. $30 billion, 30% for nuclear war prevention. This recognizes its immediacy. That could be $12 billion for arms control and diplomacy, treaty verification, de-escalation efforts.
Talking, basically.
Essential talking, yes.
Yeah.
Plus $10 billion for missile defense and detection early warning systems, maybe limited defenses. And $8 billion for geopolitical stabilization, trying to address the root causes of conflict.
Right, makes sense.
Then, $25 billion, 25% for natural pandemic preparedness. This covers $10 billion for global pathogen surveillance networks like WHO and CDC efforts.
Finding threats early.
Exactly. Another $10 billion for vaccine and countermeasure R&D, funding rapid response platforms like mRNA, maybe universal vaccines, and $5 billion to strengthen public health infrastructure worldwide. This is vital because natural pandemics are plausible and potentially existential independent of AI in their origin.
Okay, 25% there, that leaves 5%.
Right. The final $5 billion, or 5%, goes to other risks, asteroids, supervolcanoes, the really low probability stuff. Maybe $3 billion for asteroid detection supporting NASA's programs, and $2 billion for geological monitoring. The low near-term likelihood justifies minimal funding here, mostly focused on just keeping an eye out for surprises.
Got it. So a balanced portfolio, but with a clear emphasis on AI, nukes, and pandemics as the big three for near to medium-term focus.
That seems to be the takeaway, yes.
Okay, so that budget really highlights the need for major investment in AI risk mitigation. We've talked about AI being this unique, pervasive threat, partly because of its black box nature, right? Our sources mentioned this problem where more power leads to less transparency, less trust, and more strategic risk.
Yeah, it's a fundamental tension.
It's like trying to fix a car engine, but the hood is welded shut. You can't see what's going on inside.
That's a good analogy. And it leads to what they call value drift. The AI sort of loses the plot.
Like those biased hiring algorithms we hear about, or financial models that suddenly hallucinate and make crazy predictions.
Exactly. Or like an AI optimizing delivery routes purely for shortest distance, even if it means sending trucks down unpaved bumpy roads because it wasn't told to value road condition. It missed the implicit human value.
Right. It's not just a technical glitch. It seems like a fundamental roadblock to actually trusting powerful AI.
It really is. Which brings us to a potential solution mentioned in our sources, the Fractal Identity Map, or FIME.
FEM, okay, what's the core idea here? How does it tackle this black box problem?
Well, FEM is positioned as a completely different approach. Most explainability tools today are post hoc. They try to figure out why a black box made a decision after the fact.
Trying to peek under the welded hood.
Kind of, yeah. FEM, by contrast, is designed to be interpretable by design. The core claim is really profound. The structure is the explanation.
The structure is the explanation, meaning.
Meaning is encoded directly into the architecture itself. It's not something you have to deduce later. It's built in from the ground up.
Okay, how does that actually work? What are the mechanics?
There are a few key mechanics. First, self-legending semantic addresses. Imagine an address for a piece of data, like science.biology.genetics.CRISPR.
Like a file path?
Sort of, but much richer. That address itself tells you exactly what the data is and its context within a larger knowledge structure. It's like combining a postal address with a library's Dewey Decimal Code location and meaning.
Okay, self-defining addresses. What else?
Then there are weight-ordered hierarchies with short-lex ordering. It's a fancy way of saying the system is organized so the most significant foundational information always comes first when you navigate it, like a really smart table of contents that guides you intuitively.
So importance is built into the sequence.
Precisely. It's also multidimensional and self-similar, which is where the fractal part comes in. The organizational pattern these addresses and hierarchies repeats itself consistently at every level of detail, from the broadest categories down to the finest grains.
Like a fractal pattern in nature, consistent scaling.
Exactly. That ensures consistency and scalability. Then there's dynamic adaptation and drift resistance. This tackles that value drift problem.
How?
In Tumiam, changing a concept classification, its address, is a deliberate, significant event. It only happens if the meaning shifts past a certain threshold. This makes changes discrete, traceable events.
Unlike current models where meanings can subtly drift in ways that are hard to track.
Exactly. In FEM, if a concept's meaning fundamentally changes, its address changes. It's an explicit update, not a vague, invisible drift in some high-dimensional space. You can see it, audit it.
Okay. And the last mechanic.
It constrains degrees of freedom. By locking a concept's primary definition into its structural address, gives it a stable epistemic weight. Its core meaning is less ambiguous, less likely to float around compared to just being a vector in an embedding space.
Wow, okay. That sounds fundamentally different. You promised surprising facts, memorable details. Let's get into some of the really standout technical claims. Things that show this isn't just a nice metaphor, but actual engineering.
Right, this is where it gets really interesting looking at the patent literature behind FIM. There are some genuinely breakthrough concepts claimed.
Like what?
Okay, first, the eccentric architecture. is basically the sum of all the hierarchy depths across all the different dimensions in the map.
Okay, a single number representing complexity.
But here's the astonishing part. This single parameter, E, is claimed to simultaneously control search complexity, how well it maps to parallel hardware, memory efficiency, and explainability.
All from one parameter.
Yes. And crucially, the claim is that the explainability cost is OE, big O of E.
Meaning constant time relative to data size.
Essentially, yes. The cost to explain something doesn't explode as the dataset gets bigger. It depends only on the structural complexity E. Imagine asking, why did you do that? And getting a clear answer in roughly the same amount of time, whether the AI processed 1,000 data points or a trillion. That's unprecedented for complex AI.
That is astonishing. What else?
Then there's the semantic address bus. This sounds like science fiction. It's proposed as a hardware-software interface where the memory addresses themselves carry semantic meaning.
Wait, the bits of the address tell you what the data means.
That's the claim. These dual-purpose bits would encode routing information, the actual semantic meaning, and dynamic state information like importance or relevance. This enables things like skip logic hardware with 93% plus power reduction for sparse queries.
So the hardware itself understands the meaning encoded in the address.
In essence, yes, allowing circuits downstream to react contextually without extra lookups. Hugely efficient if it works.
Okay, a mind's slightly blown. What's next? The beating heart.
Ah, yes, the consistent weight block rank algorithm. This is described as the core algorithmic engine, the beating heart of FIM. It's a recursive, weight-based ranking system.
Okay.
What's novel is it uses a single, consistent role to rank and organize everything in the map, both high-level blocks or categories, and individual nodes or data points. Prior systems apparently handled these differently.
So one rule to rule them all.
Sort of, yeah. This unified approach is meant to provide intuitive navigation and allow the system to adapt continuously by updating weights recursively. It even includes something called synergy integration to capture how different elements relate to each other.
Complex relationships, not just isolated facts.
Right. And finally, there's the math behind its efficiency. Multiplicative pruning via orthogonal decomposition.
Sounds complicated.
The concept is actually quite elegant because meaning is built into the structure. When FIM searches for something, it doesn't have to scan the entire database. It can structurally ignore entire branches that are clearly irrelevant based on their semantic address.
Yeah, knows where to look.
Exactly. And the reduction in search space is exponential. The claim is the reduction factor is CT, where N is the number of dimensions, C is the number of relevant categories in your query, and T is the total number of categories in that dimension.
Give me an example.
Okay, imagine a three-dimensional map. In each dimension, there are 100 categories total, but your query only cares about 10 of them. The system only needs to inspect 2100 cubed, that's 0.11 or 0.001, only 0.1% of the total data space.
Wow, that's a massive efficiency gain.
Huge. It's what potentially makes this kind of structured approach practical even for enormous data sets. It avoids the combinatorial explosion.
Okay, so the structural transparency, the built-in explainability, the efficiency, these have massive implications. You mentioned earlier that maybe safety isn't just an ethical issue, but an economic engine. What are the economic byproducts here?
This is where the numbers get staggering. Our sources estimate the second-order economic value unlocked by achieving reliable AI alignment using something like FEMA, as the example could be, between $2.45 trillion and $4.8 trillion annually by 2030.
Trillion
Annually. By 2030, it's not just about preventing disasters. It's about unlocking enormous economic upside by engineering trust into AI.
How did they get to such huge numbers?
It comes from several places. First, enhanced AI reliability and adoption. If AI becomes genuinely trustworthy because of systems like FIME, its adoption and contribution to global GDP, which is already projected to be huge, maybe $13 trillion by 2030 could increase by an extra 10–20%. That alone is $1.3 to $2.6 trillion in added value.
Just from increased trust and usage.
Right. Then, reduced economic losses from AI failures. Misaligned or brittle AI can cause massive disruptions. Think about the 2010 flash crash in the stock market, a temporary $1 trillion loss blamed on algorithms. Preventing just one or two major AI failures like that per decade could save $100 billion to $500 billion annually on average.
And that's not even counting smaller failures.
Exactly. Plus, something like over 80% of current AI projects reportedly fail to deliver value. Better alignment directly tackles that inefficiency, saving billions in wasted R&D.
Okay, what else contributes?
Improved goal definition and fulfillment. An aligned AI is simply more effective at achieving the right goals. We see studies where AI boosts worker performance by 10% to over 50% in certain tasks. Aligned AI makes that boost more reliable and targeted.
Makes sense. And you mentioned something about options pricing.
Yes, this is a really novel concept they introduce. Pricing AI competence risk. like options.
How does that work?
Think of the money we invest in AI safety and alignment research, maybe that $520 billion a year from our hypothetical budget. You can view that investment as the premium you pay on a financial put option.
Okay, the cost of the insurance.
Right. And the strike price of that option is the potential economic loss from AI failures, that $500 billion a year we just talked about. By investing in alignment, you're hedging against those massive potential losses.
So it turns this abstract fear of AI risk into something quantifiable.
Exactly. It turns it into a quantifiable, potentially insurable asset. They call it creating a trust option multiple, where the guarantee of reliability, the insurable competence, becomes economically more valuable than just the AI's raw output alone.
Insurable competence. That's a powerful idea.
It really is. And there are other byproducts, too. Increased public trust is a big one. Only about 39% of Americans currently trust AI in the workplace. FA could change that.
Which would speed up adoption again.
Right. Plus, reducing inequality if AI benefits are distributed better, avoiding huge regulatory fines like under the EU AI Act, maybe even environmental gains from smarter, more reliable systems like optimized power grids.
That insurable competence idea is transformative. But thinking competitively, how do you actually get companies in a race to adopt something like FEM, even if it's better long term? Isn't there always an incentive to cut corners for speed?
That is absolutely the core challenge in AI development right now, the race dynamics.
So how does FEM address that?
Well, the argument is that the economic benefits themselves become the incentive. If FIM, or something like it, makes AI demonstrably more reliable, less prone to costly failures, and potentially not much slower to develop due to its structured nature.
If the safety doesn't impose a huge speed penalty.
Exactly. Then the competitive advantage shifts. Having insurable competence becomes a massive selling point. Customers, regulators, investors might start demanding it. The market itself could drive adoption because the risk of using non-auditable, brittle AI becomes too high.
So safety becomes a feature, not just a cost.
That's the hope. The economic argument for alignment becomes overwhelming.
Okay, let's bring this full circle. Back to the doom train we started with. How does a potential solution like FEM, this transparent, verifiable, maybe even insurable competence, change the odds? Does it actually function as one of those breaks?
It definitely impacts a couple of those key breaks we talked about, particularly the efficacy of human coordination and governance break.
Which we call the ACE.
Right, and the competitive and geopolitical dynamics break.
Okay, how does it help governance?
For governance, FIAM provides the technical underpinning that makes effective governance feasible. Right now, it's hard to regulate AI because it's often a black box.
You can't enforce rules you can't verify.
Precisely. But if AI systems are inherently transparent and auditable by design, like FEM claims to be, it enables verifiable competence. Abstract policies can become concrete, enforceable architectural constraints. It makes the argument we have a safe AI development process much more credible. It strengthens the case that super alignment is tractable from a practical governance standpoint. That off-ramp looks much more solid.
Okay, so it makes governance technically possible. What about competition?
For competition, the key is whether building safe, auditable AI using FIAM is significantly slower or more costly than building unsafe AI, if it isn't significantly slower.
Which the efficiency claims suggest it might not be.
Right. Then the incentive to cut corners purely for speed diminishes. And that concept of insurable competence strengthens the argument that maybe capitalism solves alignment, because safety itself becomes a marketable, valuable, competitive feature. Why buy the risky AI when you can buy the reliable, insurable one?
Interesting. So what's the overall impact on the doom train calculation?
Well, obviously the exact numbers are highly speculative, but incorporating the potential impact of a technology like FEM into that calculation, it significantly lowers the aggregate probability of catastrophic failure. It improves the odds for those specific breaks, governance, and competition dynamics. It suggests our chances of navigating these risks successfully are higher because we might actually have a tool designed to address AI's unique transparency and alignment challenges head-on.
So we've really taken a journey today, from the pretty terrifying probabilities of various existential risks.
Yeah, started with the scary stuff.
Right. All the way to this surprisingly detailed architectural solution for AI alignment. The challenge, as top experts like Jeffrey Hinton and Yoshua Bengio keep warning us, is immense. They say AI alignment should be a global priority alongside other societal scale risks, such as pandemics and nuclear war.
And our budget allocation reflected that priority.
It did. But what if the very framework we use to build AI could transform its greatest risks into its greatest strengths? If something like this fractal identity map really can turn AI competence into an insurable, auditable asset, something you could literally price like an option.
It changes the entire value proposition of safety.
It really does. So the final thought maybe is, what does that imply for how we invest in and how we trust any complex system in the future, whether it's human or artificial? If we can engineer and verify competence like this, well, it seems to open up a whole new world of possibilities, doesn't it?
It certainly gives you a lot to think about regarding the future of trust and technology.